Alright, we're doing 9.2, which is the substitution method. We just finished 9.1, which was the graphing method, and these are all working with systems of equations. We're using different methods to solve these systems of equations. Now, we did it by graphing, but that is not the only way you can do it. You can do it many other ways, and most of them involve not graphing, and they're a lot easier, and especially if you have something that's not a precise coordinate, this is really helpful. So we're going to be using the substitution method this time. So the steps for the substitution method, first, if you do not know what to do, just come to these steps and follow these steps. So these will be very helpful as a resource for you. Okay, so step 1, solve one of your two equations for x or y. This means that you're going to pick one of them, and then you're going to solve for x or y. If you solve for x, you're going to have x equals something. You're going to get x by itself. Or if you solve for y, you're going to have y equals something, and you get y by itself. You get to pick. You pick which equation you want to use, and then if you want to solve for x or y. I choose the ones that are the easiest for me. So, number 2, you need to substitute this expression into the other equation. What that means is you're going to have your x equals something or y equals something, and you're going to take that and substitute it in for the x or y in your equation, depending on what you pick. You'll get to see that in just a second. And then you're going to solve the resulting equation for the remaining variable. So you're only going to have one variable left once you do that substitution method, and you're going to find what you get. You'll get either it's x equals something or y equals something. It'll be an actual number. And then once you have that, you're going to use the variable that you just found, which is the x equals a number or y equals the number, and you're going to solve for the other variable. So it might sound that's an A. Let me just fix it. Variable. Okay, so once you have one of them, then you can plug it back into one of the equations and find the other variable. This is kind of sounds a little bit difficult just because it's so arbitrary. So I'm going to show you an example, and hopefully we're going to use these steps to kind of figure that out. So the first one right here, it's solve 2x minus 3y equals 4 and x plus 4y equals negative 9. So the first thing is to solve one of your two equations for x or y. Well, that means I need to get x equals or y equals. Well, if I look at the second equation, I can easily get x equals without even having to divide. I don't like to divide. It's not as fun, especially if you have fractions. So I'm going to subtract 4y on both sides. I'm going to have x equals negative 4y minus 9. So I changed this equation into this, and now my two equations are this one, first one, and this one, and that's what I'm going to use right now, as of now. So now I'm going to substitute this expression into the other equation. So I'm substituting this x equals negative 4y minus 9 into my other equation. Basically, I said this part is what x equals, so I'm going to plug that in for my x. So I'm going to write 2 times, what does x equal? We told you that it's negative 4y minus 9, and then I'm going to do minus 3y equals 4. So I took this part from this equation and plugged it into the other one. So kind of meshed them together. And now I'm going to only have one variable. I only have y, and we can easily solve one variable by simplifying and isolating y. So it says solve the resulting equation for the remaining variable. So that's what I just said. So we're going to solve for y for this. So I got to distribute. So that's going to be negative 8y. Distribute, that's going to be negative 18 minus 3y equals 4. I'm going to combine like terms, so negative 8y and negative 3y is negative 11y. And then I'm going to have minus 18 equals 4, add 18. So that will give me negative 11y equals 22. So I'm going to divide by a negative 11. So that gives me y equals a negative 2. So now I found y equals a negative 2. So now I need to use that variable that I just found to solve for the other variable. So I have y equals a negative 2. So if I plug that into either one of my original equations, I'm going to pick the second one because I just did. Okay, so I'm going to plug it in. So I have x plus 4, I'm going to draw a line so you have 4y, but we know y is now -2, equals a -9. So x plus, which is really -8, equals a -9. Add 8 to both sides. So you get x equals -1. So once we have that, we have our coordinate point. We have an x and a y, so we have -1, -2. So if you were to graph it, that is where they would intersect. There you have it. Okay, oops. So now we're going to solve another one. Same thing. What's the step 1? Step 1 was to pick one equation and solve for x or y. Again, I'm going to pick the second one, and I'm going to add 4y because it's super easy to get x by itself. So I have x equals 4y plus 8. My second step is I'm going to take this new equation, the x equals, this is what x equals, and I'm going to plug it into the other one. So I'm going to plug in 4y plus 8 as x. So I'm going to say 2 times x, which is 4y plus 8, minus 8y equals 6. So now I'm going to distribute, because I need to solve for my remaining variable, which is y. So I have 8y plus 16 minus 8y equals 6. So 8y minus 8y is 0, so I'm left with 16 equals 6. When does 16 equal 6? Never. So if this does not work, if you get to this case, you would say no solution. Remember how we said that? We'd be like, because that's a false statement, no solution. What if we were to get a true statement? What if we got 6 equals 6? It would be all real numbers, or that would mean that they're the same line, kind of like what we did when we graphed. So there you have it. Hope you like this method.